Good morning, everybody. Welcome to our Friday morning space show program. And I am your host for the program, David Livingston. Thank you very much for tuning in. And we hope you enjoy our program today. We are honored to have David Eicher, the editor emeritus of Astronomy Magazine, with us. And If you can see down here, this is his picture. And before we get into a full introduction for him, and before we really get rolling, a couple of quick announcements. There is no program for Easter Sunday. So the next time we convene will be on Tuesday, and Bob Zubrin, our Mars guy, is back with us. So we want to make sure that you know that there's no program on Sunday. And for today, we're a variable time length, and so the team and David will be with us, and we hope we hear from you. And some of you have logged in via Zoom telephone numbers to participate in this discussion. Our guest, David Eicher, has written about 26 books on science and history. He's a board member with Starmus Festival and the Great Lowell Observatory. And he was editor-in-chief of Astronomy for quite a while, 2002 to 2025. But he was part of their staff. Well, that goes back even longer, 1982 to 25. So this is him right here, and he doesn't look like he's old enough to have retired. So, David, welcome to the space show. And I'm not going to ask you your age, but why did you become emeritus? Because you look younger than the rest of us here.
Well, thank you for having me, David. It's really a pleasure to be with you. And I think when I started as the junior assistant editor at Astronomy Magazine, I was barely able to shave. That was a long time ago. So I've finally gotten to the point where I'm doing some things for the magazine, but also some other activities now too.
I always wondered, and this may be an unorthodox question, did you, did Astronomy Magazine in general and you as editor feel hard competition against Sky and Telescope, or did you see that you served different markets and you were differentiated and they really weren't competition in the astronomy world of generally available publications?
That's a good question. And I had many friends at Sky and Telescope over the years, still have them. And I'm doing some writing for them now as well, now that I'm retired essentially. But, it's funny, back in the old days, Dennis DeCicco and Norm Sperling were there. And I heard, when astronomy was kind of the upstart. And they're really complementary magazines. Astronomy is much more focused on beginners to intermediates. Sky and Tel is more advanced. And of course, the American Astronomical Society owns it and publishes it now. So they're really, I think, complementary. But the friends at S&T told, when Astronomy Magazine came in the mail, they stopped what they were doing. They sat down, they paged through, they talked about it, probably made fun of it. But in reality, it's a complementary group to serve all the people who are interested in astronomy and space. And I think the magazines really didn't overlap as much as people seem to think. So it was kind of a standing joke between the friends, the editors there, back and forth, that they were trying to wipe each other out. That was really never the case.
So I was a subscriber in high school, so it's probably junior high, probably around the very early 60s, and I subscribed to both. So I could read and understand everything in astronomy. And Sky and Telescope had great pictures and had great ads. Learned a lot about telescopes just through the ads in both magazines.
Yeah.
And probably 80% of the articles were so technical that I could not follow them because I didn't have the math or the astronomy background to follow them in high school.
Sure.
But
Sure.
with Astronomy Magazine, it was a great teacher. It was like having an updated modern astronomy textbook delivered to my house every month, also with great pictures. So I saw a difference between the two. So, but I was a high school reader, so that was probably not your market. But I valued the fact that one I could comprehend and one was way over my head, but I wanted to take it anyway because I love the subject matter.
Well, thank you. And that's very nice to hear. And astronomy always had the mission statement of, making things very clear and understandable to a smart person, but who's not trained as an astronomer, without oversimplifying the technical aspects of what's going on. And I think Sky and Tell has really changed and become a lot more friendly in recent years with its language. But back in the day when I was a teenager, that's a long time ago, but I sat down in Joe Ashbrook's office. He was the editor at S&T then. And he said out loud to me when I was thinking, where do I want to go and work as a journalist? And he said, well, Sky and Tell is a magazine for professional astronomers financed by amateurs. That I think he said that a little tongue in cheek, but they sort of took it as a moment of pride back in the early days that it was as technical as it was. So they are very different magazines, but I think Sky and Tell is a lot friendlier, a lot easier to read now than it was 40 years ago.
So I have noticed, and I'm sure others have too, that over the years, the rate of astronomical, cosmological, astrophysical, however we want to describe it, discoveries is at a phenomenal pace, um, over what it was when I was starting to pay attention, at 10, 12, 11 years old. So we're going back then into the late 50s.
Yeah.
What do you attribute the incredible pace of discovery? Is it because of Hubble or or just computers? What opened the door to all of this? And I do a segment with John Batchelor every Wednesday. It's about 20 minutes. It's his show, and I'm a co-spokesman on the show. And he likes to focus on nature and science journal articles. And the amount of published and reviewed articles that have a cosmological orientation, whether they're little red dots or whether they're Vera Rubin or whatever, is so beyond what you can keep track of that it's unbelievable. Something had to open the door to that. What do you think that door opening was? It one event? Was it a bunch of events? What did it?
That's a really good question, and I think it's a conspiracy, if you will, of a number of things working better together over time. We've probably learned as much in the last generation about the universe and how it works as we did in the century before that. And so it's really a golden age for astronomy, astrophysics, cosmology, planetary science. Some of it is more exploration with mostly with unmanned craft, mostly until this week here in recent times. But a lot of it is science building on what we previously have known. Now, mind you, we don't know a great deal still. That doesn't mean what we do know is wrong, but we don't know the nature of dark energy, what it really is definitively, or dark matter, and they make up the majority of the universe. So that's another question, but that's complicated. But science is a self-correcting process, and it builds on the results that came previously with experiments, with observations, with so on. And we have so many craft now and so many astronomers employed working on finer and finer points in many ways that we're learning more and more details of the way the universe works. I won't go on forever about this, but now we know, which we didn't know 50 years ago, the age of the universe fairly accurately. That's because of a couple of orbiting observatories that are very specific. And we know the Big Bang definitively happened as the origin of our cosmos. We know the size of the universe. We believe we're leaning toward, we know what the fate of the universe is going to be 100 billion or more years from now. Although there's a wild card in there, the nature of dark energy could change that a bit. But so a lot of these big questions that we know about how the universe worked, how stars forms, how stars formed, how many galaxies there are in the cosmos, more or less 100 billion. We didn't know those definitively a generation ago. We know the answers to those now. So it is an incredible period. And it's really a conspiracy of more people working on finer points, more instruments, more telescopes in space and on the ground, looking at all these things and giving us discoveries.
Another point on this is when I was younger, and again, this would probably include from 56 on, and I was 10 years old then, um, you could actually get fairly good science information from TV. So there
Mm,
were the three networks, but usually if Walter Cronkite was doing a space segment, it was
yep,
pretty accurate. Huntley
yep,
Brinkley was. Jules Bergman over at ABC was
yep,
excellent. And then
yep.
something happened. I personally think it happened around the time of the Vietnam War.
Mm-hmm.
And I mean, that's my personal turning point. But after that, media has not been a good teacher for science. And often, when they report a story, even Artemis, as we were talking about before the show started, it's not even accurate. What
Mm-mm.
happened? What, from your perspective, altered TV as kind of a useful learning tool for people about everything science, not just space?
Yeah, it's really scary. And it's not just science either. It's politics, it's what's going on in the world now. And I think we're in a really kind of a dangerous place. And it gets into, I forgive, I don't want to do a long discourse on this all of a sudden, but I think it gets back to how people believe what is true. And this gets to what's called the philosophy of science. And, 2000 years ago, we would have intuition as a major important way that you determined what you thought was going to happen. I dreamed this, so I think it may happen. That doesn't turn out to be very accurate. On the other end of the spectrum is empiricism, is science, is testing observations, repeatedly testing, having other groups test or experiment and make observations and come to a conclusion of the way reality is. In between those things are other methods that are less accurate as well. One of them that is predominant, I think, now in our world is authoritarianism. And that's, well, my parents or my teachers or the television told me this, so I believe it. That's one of the weakest ways to understand the way things really are as well. And it goes back to probably primal feelings. 100,000 years ago, if you didn't agree with your hunting group members you were in, you could be cast out of the group and have no food and die. So this feeling that you have to agree rather than independently think about things with your parents, your teachers, with TV anchors who are not very good with science now, whomever it is really predominantly strong. And I think that goes back in the human psyche a long, long way. And what science tries to teach is independent thinking, which is harder and takes a lot more effort. And most people don't think or analyze things independently. And I think that explosion of just, I heard this, well, I heard that, it's true, that sort of exploded in the 1960s with television and with other things. And so a lot of people think a lot of things that have nothing to do with the way the universe really is.
Rapidly moving forward, I'll
Yep.
do one more question and see if the panel wants to jump in.
Mhm.
On modern times, we have this plan by various companies, including Musk, for data centers in space, on the moon, mass driver on the moon, etc. So many environmental groups and others have said, no, 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 you're going to muck up the skies for observing, and we're not going to be able to do it. And part of the reply is that with AI filtering the digital telescopes, because no one's looking through eyepieces anymore except amateurs, um, they can filter out the light streaks, and you won't notice the data centers or what we're putting up there, and it will not affect night sky viewing. Although an amateur, if they're using an eyepiece, might have it affected. And that's not being widely accepted by the people who are protesting this effort. What are your thoughts on putting all of this additional reflective light instrumentation in LEO on the moon, data center, solar collector? Is it going to alter our night viewing sky? Is it something we should be doing or not doing? From your perspective, please.
There are a couple thoughts here. I think the genie is kind of out of the bottle. I don't think we're going to stop this, the proliferation of satellites in orbit. It is a real problem, a serious problem for professional astronomy. And, despite what Elon or others might want to say, you can't just subtract streaks out of imagery and make up data and just put in imaginary data where the light was. That doesn't really work when it comes to astronomical research. So it's a serious problem. It's only going to get worse. There's a tremendous amount of stuff in low Earth orbit, of course, already. And this may explode in the future, and it's a pesky nuisance, if you will, for amateurs. The world of amateur astronomy is seeing sort of a growth phase of astrophotography because of these smart scopes and so on that exist now. It's easier to do than ever. It used to be that astro imaging back when I was young was like being in a prison camp, guiding things on an illuminated crosshair eyepiece. Now it's much easier. It's going to muck things up for the wide field imagers, but for professional science, it's a serious problem that's coming. And I don't know how that's going to be resolved, because you can't just subtract satellite trails out of professional images, plates that need to be measured, stars that need to have their brightness measured, and asteroids and other phenomena that are showing up or not showing up. That kind of screws up the whole paradigm of examining data for professional astronomers. So I don't know where that's going to go, but it's not going to be pretty.
Do you see any good compromise suggestions coming out from either group or regulators or other countries, maybe?
There are discussions going on, and one of the ex-director of Lowell Observatory is a guy who's on the panel with the American Astronomical Society to discuss light pollution. And it kind of goes along with the discussion of light pollution from astronomers' point of view. Jeff Hall is his name. And so they're discussing things, but the regulations really, there's not much that can be done to hold companies to bay, whether it be SpaceX or anyone else, to follow any kind of regulations in space. So it's going to be an uphill battle, I think, for astronomers not to have real problems increasing with their research, especially with wide field images. And a lot of these new telescopes, the Vera Rubin telescope in Chile, the best sky is in Chile in the Atacama Desert. So that's where a lot of big telescopes are going now. The Rubin telescope is a huge field survey telescope, taking many images per night. That's going to be a real headache for these surveys that want to tell us more about the nature of the deep universe.
Does this make the case that all future telescopes should be orbital or space-related
That's
telescopes?
a very, very good question, David. And it may, as time, I mean, we've just started this, and we hope we're going to be around for the better part of another billion years if we don't have too many wars. until the sun, boils the oceans off of Earth. That's going to kind of end the party on the planet here. But a billion years is a long time. We've just started this business about putting more satellites up into orbit. So I really don't know where that's going to go, but it's going to be a much bigger problem in the future. So it may be that more telescopes have to leave the planet and be in space to avoid this. You're exactly right about this.
Of course, that doesn't help the amateur.
No, the amateurs are going to be in an increasingly pesky world. Of course, it's not so critical that if an amateur has satellites passing through their astrophoto, it's not the biggest deal in the world, maybe, but it's going to frustrate them. But there's not going to be any way around that from the surface of the planet.
Mar Marshall, you have your hand up, and I think Bill also wants to jump in. You're muted, Mike.
Since I'm unmuted, you want me to go?
Yeah, go ahead, Bill.
Okay. Yeah, so I'll jump in on this same topic a little bit because one of the things that you used to hear a lot about is moving, I guess specifically radio telescopes to the far side of the moon. But now it seems like there could be a lot of radio noise from these orbital assets that would be associated with this proposed cislunar economy. So at this point, should we just abandon that idea and go, put radio telescopes in deep space like we do optical telescopes?
Well, I think that's again a very good point and question, and I think that's increasingly going to have to happen. And of course, the problem with that is it's really expensive, to put stuff into space. It's even more expensive to take stuff to the moon and to try to build it there. That's an era we haven't really even entered yet. So yes, those are good solutions. They're probably going to have to eventually happen, but they're going to be enormously expensive in terms of time, engineering, and true costs. So will that sort of turn off the faucet on many of these projects? We don't have a country that's very interested in science right now. So, maybe things will change in the future. But in terms of funding, it's really difficult to try to get governments to do this. And in the future, the ambition of building things on the moon, of going to Mars, the expense, the sophistication, the radiation exposure of long-term travel and so on, those are projects that are so big. We've been talking about those since the 1940s and 50s in sci-fi booklets. Those are so big and so expensive, they're probably going to have to be joint governmental, private industry, and maybe multiple governments being involved to really do some of those things. They're so ambitious and so costly, really, to do.
Yeah, and I guess with regard to the science, this doesn't seem like a time when we're really willing to invest in science. It is heartening. It is heartening that Congress did maintain funding for the National Science Foundation and NASA Science in the face of the proposed cuts from the administration.
That's absolutely true. Yep. It could have been worse. It's not great. We have a lot of astronomers and other scientists who have left this country and gone to Europe or Asia, and they're not going to come back. So, at this point in their careers, so there's going to have to be a renewal of science in the future with younger people getting into it. But you're right, it's not a total disaster, at least at the moment here.
AJ?
Well, today's news, they just proposed cuts to NASA's budget. So check the latest news.
Yeah.
So it'll be another fight again this year.
Well, and it's not going to be good in the short term any way you slice it here. There's already been tremendous damage to the world of science, to the number of scientists who are working in this country, talking in a nationalistic sense. Most of the other nations in the world that have science programs still realize how science is really important. So this is a fundamental problem that's unique to our country right now, as far as the wealthy nations go.
AJ, you want to talk?
Yeah, sure. The cross-section area of a data center, orbital data center, is much larger because of the radiators and of course the solar panels, etc., than just simply these COM satellites that small that they have been that Starlink, etc., that have been put up there.
Yep.
So that would make a hell of a difference, much worse for astronomical data and what you just described. What Elon is trying to, putting up talking about million data centers in orbit, etc., is it's just really just going to be much worse than the Starlink type of thing. Is that correct?
Yeah, and if we get to the point where we have many, many satellites that are equivalent to first magnitude stars in the sky, then it's going to be a really, really grave problem. Amateur, professional, whatever you are, you're going to
Yeah.
have a disastrous problem trying to take data then in the world of astronomy, regardless of what you're doing. So that is correct.
Okay.
What
And
about what about
another
the
question.
telescopes that cut through the atmosphere to improve the imaging here on Earth? You know, the newer way of doing ground telescopes. Can they cut through the brightness of all of this that's going to be added into, say, LEO or near Earth space?
Well, there's technology that's been in existence and it's expensive and complex, but it's been around for a whole generation now called adaptive optics.
Right.
And by having the mirrors that are relatively thin for very large mirrors with push and pull motors to in real time change their shape slightly to compensate for atmospheric turbulence. That's been going on for a while. All the big new telescopes that are being built now have that incorporated, of course, but that doesn't do anything to take out bright objects that are in orbit that cross your field.
Marshall.
The story about the power blip. A couple of weeks back, Dr. Siegel was on, and I got him very excited by asking him about really big telescopes that could be put into orbit by Starship. And then I did a little spreadsheet because that's what I do. And I kind of went, wait a minute, the adaptive mirrors on James Webb is 1.3 meters.
Yeah.
And with Starship, you could run them up about 5.5 times larger.
Yeah.
And you could stack them up and assemble them with robots, and you'd get a total light collecting capacity 78.6% larger than we have before. So it's kind of like your total light gathering would be 91.8 times that of the Hubble Space Telescope. Do you think that would satisfy the professional astronomers?
It would keep them
Particularly if
busy.
they, like put up 6.
Yeah, it would keep them busy for a long time to come. And all we could do that, all it takes is money. If we decide to spend the money in that direction, we could do things like that. And even, the Rubin images, the early release Rubin images, I was up at the American Astronomical Society meeting a couple months ago, now, whatever it was, in Phoenix, their winter meeting. And we saw the first Rubin images on a planetarium dome there. And they're able, these are wide field images, relatively speaking, but they can zoom in on tiny pieces because they're such large files, if you will. The chips in the Rubin telescope are incredible. So, there are problems that come with this kind of great research. We could do the same thing with a much larger space telescope. I think that a team of 100 young astronomers are going to be busy for the next 50 years just reclassifying galaxies, because you can what was a tiny smudge in Hubble or James Webb imagery, now you can see the morphological type, that is the type of galaxy that it is pretty plainly in these Rubin images. So there are going to be explosions of knowledge, of advancing what we know, and we may not be able to catch up quickly enough to interpret it all. And the same thing certainly could happen on a larger scale if we had a really large space telescope. That point you just made, absolutely true. And all it takes is getting, governments that care about science and knowledge. We don't have that in every country in the world right now.
Well, I'm hoping that we can kind of coax Elon into quote unquote sending one into space and then getting other people, so you have the Musk telescope, and then we probably have the European common markets, and maybe Japan, Australia, but it's always the first one that's the hard.
Right. And that would be explosive. If Elon decided he wanted to take a big chunk of money and make a space telescope that's 5 times the aperture, of say, Hubble, it would be revolutionary. The things that you could investigate and the push, we talked about how much more we know now than 40 years ago. This would be an explosion of knowledge potentially with a telescope of that size in orbit. Doubt about it. So all it takes is the will and the money, and we could have an avalanche of information, and probably, maybe we could find out, definitively, is dark matter made of little axion particles, which presumably it should be, or although we haven't found them in a collider yet, and what the hell is dark energy and how does it work? Maybe it would solve some of those questions, and we would find out what more than 95% of the universe is made of, which at some point is going to be important to know. The baryonic stuff, the bright stuff, the cats, dogs, trees, planets, stars, us, that's, a tiny fraction, about 4% of the matter energy in the universe. So we don't fundamentally understand what most of the universe is made of still. Which was a driving thing that Einstein was trying to figure out.
And my spreadsheet tosses out a number of $2 to $3 billion, which to Elon is chump change.
Elon's got plenty of billions. If he really wanted to do such a thing, he could do it. There's no question. Yeah. So, we need to get some of these folks interested. Well, he's interested, but even more specifically interested in that, it would be revolutionary.
Yeah. That's enough.
We do have a lot of citizen science and citizen astronomy.
Yes.
So as technology moves forward, as AI data centers, things like Vera Rubin and stuff move forward, is citizen science and citizen astronomy going to grow in value and importance, or is it maybe going to get passed over because the real technology, the big stuff out there, is going to be delivering the goods and the citizens aren't going to be able to compete?
That's a really good question also. And if you go back to when I was young, a long time ago, there was the professional astronomers got people involved in various astronomical projects. There was the American Association of Variable Star Observers, all sorts of organizations taking and using amateur data, if you will. Back in the day, amateur astronomers produced a lot of stuff, and they were technologically limited, of course, to the equipment they had. But the professionals took it, thanked them, this is a wonderful thing, contribution, and stuck it in the drawer. Now you really can't, right now, not even in the future, now there are a lot of amateur astronomers because the technology, the cameras, the calibration of the equipment, the measurements of brightnesses of things that they're doing is so much better than it was 30 or 40 years ago. There are now amateurs in a much wider sense contributing to published papers, scientific professional papers, whether it be astronomical journal, astrophysical journal, whatever, where amateurs are contributing. There are amateurs at the observatory where I have the most inside knowledge, Lowell Observatory. There are amateurs contributing to various asteroid, comet, and variable star projects there, contributing the data, and it's relied upon. So that revolution has already sort of happened, which, it used to be sort of acknowledged and joked about by professional astronomers a bit behind, the backs of people. Now it's really happened. In the future, it will only get stronger, that contribution by amateurs, because there are not enough professional astronomers to investigate everything they'd like to investigate. So they do need the help of an army of really well-appointed amateurs if they can get it.
AJ, go ahead.
Yeah.
AJ, yeah.
Yes. Yeah. I'm really pleasantly surprised that the amount of attention from public that has come about because of Artemis that took off 2 days ago, and did the TLI yesterday, etc. And I did not expect that. And I did not think that the people would be so excited about that. That kind of an excitement generation that the new moon program and other things are generating in public and all that, would that also help the astronomy part of that part also? So, I mean, I would think that they would, because it is really exciting for people to learn about space and, of course, go there and all that. But just to be in it and to be, excited about it would probably help a lot of students and, of course, the amateur people and the next generation and all that. What do you think?
I absolutely agree. And there's an old friend that I and many other people had. He's been away from us for a long time now, but Carl Sagan used to say that, 99% of everyone, humans on Earth, are born, live out their lives, and die without ever realizing their place in the universe at all. They're focused on a 2D landscape on their planet. It's a hard thing to live through your life and do everything you have to do. And the Apollo program in the 70s, 60s and 70s, it really exploded astronomy as an interest in people's minds. There's only one other thing that has contributed, like the Apollo program in modern times, to the interest in astronomy, and that is when there's a really bright comet in the sky. And the really good ones that lingered for a long time, you have to go back a ways now, were Hale-Bopp and Yakataki in the 1990s. But a really bright comet that you can bring, your, sister-in-law in the middle of the night out, and she rubs her eyes trying to wake up and says, "Oh my God, that's unbelievable." Something that's that bright also does that. So we don't know, but and society has changed. And now everyone, especially everyone, who's younger than 40 or 50, is looking at everything, right here all the time, all day, and so the parameters are different now. But I expect that Artemis in this program will have an infusion of people being interested and aware of science and how big the universe is. Our sun is just one star of maybe 300 or 400 billion in the galaxy. There are 100 billion galaxies in the universe. That awareness of how small we are and how fragile our planet is, and it's still the only planet in the universe where we know life exists, will come to more people, and that will create another wave of interest in all this stuff, I think. But we'll see.
Thank you.
John Jossi, go ahead or just start speaking.
Yes, you mentioned people getting excited about comets. So back in 1986, when Halley's Comet came by, that's when I went out and bought a C8 and became interested in astrophotography.
Yeah.
And so, I would take that out to dark skies and take pictures. And I thought I was really advanced with hypersensitized film.
Oh boy,
where you cool the film down with whatever and increase the light speed and all that. And it's all gone away.
Yeah.
And so what really annoyed me when I would take photographs, even back then, is the satellite trails.
Yeah.
And we talked about that a little bit earlier in the show about that degrading scientific data. But if you just want to take a picture, I was curious, so I asked Grok, are there software applications for amateur astronomers to filter out satellite trails from digital images? And the answer is yes. There's a ton of them for stacking software for satellite trail rejection and that sort of thing. So what can you say about that? At least that's some mitigation that we have for at least imaging.
Yeah. There are programs that can eliminate trails in astrophotos, whether they be from satellites or asteroids or what have you. And there's not magic. As Richard Dawkins, one of our Starmus pals, like to say, you can't magic your way into the universe. So those will eliminate those and make your especially your wide field astrophotos prettier. But they're not. It's not magic. They're not. They're just replacing those pixels with the background sky. They're not. So these trails of stuff that go through an image, you don't know what was really there behind the trail. So they're not they're not eliminating the presence of the satellites. They're just coloring in the satellite trails to be like the background. You know what I mean? So it's not, you can't eliminate them from reality. You can color in the trails, if you will, by software and get them out of your pretty picture of the Orion Nebula and stick it up on your wall or whatever you want to do with it. So it's a solution on a sort of a very narrow, thin level, but it doesn't really solve the problem. It doesn't solve the problem at all for professional astronomers who want to know what's the data that was behind that satellite trail. That's what I'm looking for, and that's gone. You can't just make that up out of the blue.
Well, one thing just occurred to me as you're talking about this. When we see satellite trails, it's only during a very narrow slice of the dusk and dawn, right? So
mostly, and it depends on the elevation of the satellite and the sun angle, mostly because of the sun angle and because most of this stuff is at a certain altitude above Earth. It's really much worse in the post sunset and pre-dawn hours. Yes, but it's not.
Right. But what I'm thinking is there's a lot.
They're high up in the middle of the night, going through things. Yeah. So it's
that's it. That's exactly what I'm thinking. And there's going to be a large majority of the time when satellites actually aren't lit but are blocking the light of the star.
Right.
In which case you wouldn't see a satellite trail.
That's true. And you think there's some kind of strange occultation going on, and it's an occultation, but by something that's only 300 miles away. Right. And that's a problem too. But that's too sophisticated to be much of an issue for amateurs. That's really a problem for professional astronomers and large telescopes. Yeah.
What scares me is what you mentioned about how these satellites or data centers and all that can also cloud up the asteroid. So for planetary defense angle, that could be very scary, that we would not see something that may be coming in time enough or something like that. Do you think that that's possible?
It could be. And if you look at a record of the large impacts on Earth throughout history that we know about, the KPG impact that killed off the dinosaurs 66 million years ago, but other there are several dozens of major impacts that we know about that occurred on Earth in history. Those aren't going to stop just because we know about the previous ones now, So there are still things that are out there. The good news there is that there is no 10-kilometer or larger civilization killer, the KPG impact size in near Earth space in the inner solar system. However, such an asteroid or cometary nucleus could come from close to the sun and be undetected by us and then impact Earth. It's unlikely it could happen. But even if we have, you know, a 100-meter asteroid come down and hit in, you know, Times Square, that's going to be a bad
city killer, say for
planet
example,
Earth,
something.
you know, so it doesn't have to be a civilization killer. So cataloging asteroids in the, you know, main asteroid belt, in the Kuiper belt, out in the distant solar system and elsewhere, we now have, just in the last few years, since we have the capability to do this at all, we have, depending on what you believe, 2 or 3 or 4 or slightly more interstellar objects coming through our solar system. That makes sense. There's no net, you know, out, you know, around the Oort cloud. There's stuff that's going to pass through us as well, because there's a lot of stuff in the galaxy, you know, near us. So, you know, what do we do if we discover that there's a major asteroid of some size that's going to impact Earth? We don't know of one right now, but that's, you know, it makes for great science fiction stories, but it's going to happen if we wait long enough. You know, it may be another 100,000 or 10 million or 100 million years, but eventually there's going to be a major impact from an asteroid into Earth again, and that's going to be something that we'll have to deal with.
Yeah, I was talking more about city killer type of asteroid, not civilization killer, which can be, you know, detected, but city killer types, you know, that may go undetected until the end, until late, let's say, you know.
Well, and we have a really good catalog of the asteroids. Thankfully, the asteroid that is named after me is not going to encounter Earth, so I won't be the greatest criminal in Earth's history. But we know of many, you know, tens of thousands of asteroids now that are in the main belt and elsewhere and closer in, so-called near Earth objects, and of course out in the Kuiper belt as well. And those are pretty well known and pretty well cataloged. There's no significant object that's going to impact our planet anytime soon. However, a smaller asteroid, of which, of course, when you're talking about smaller than civilization killers, there are more of those as well, of course. Those could come in, you know, from close to the sun in our sky, and we may not have much time to react to that. So that could be you know, if we run the clock long enough, that's going to be a problem we'll have to deal with at some point. And what could we do about that now? If we discovered one now and we knew we had, you know, 6 weeks or 3 months or 6 months to prepare, we'd have to scramble, I think, to get a defense mechanism up there. In the old days, when they first started talking about planetary defense, generals at the Pentagon and so on, well, you go up there and you blow it up, you know, but then you have buckshot coming through. So, you know, you need to, as Sagan and others even years ago talked about and worked on, you'd have to detonate maybe a nuclear explosion near this object and nudge it out of its intersecting orbit with Earth. That could be done, but we don't necessarily know we would have enough time to launch a mission to do that, which I think goes to your point.
Yeah, no, I was really, worried about the fact that all these data centers and maybe not other satellites, but data centers, a million data centers can certainly cloud that.
Well, that's certainly possible. They could get in the way of detecting all sorts of things. That's absolutely true. Yeah. And I mean, that's an unexplored frontier. That could get much, much, much worse as more of these are launched. And we don't know what the outcome could be from that. That's true. Yeah.
Jossie, you have something you want to say?
Yeah, I'm really excited about Eric Schmidt's recent funding of a space telescope that will rival Hubble, and it's only 4 years away is when it would start operations. What do you think about that? Are you excited about that?
I'm very excited about that. And as we kind of dipped our toe in momentarily there earlier, you know, more and more of this may have to come from wealthy private citizens rather than necessarily thinking everything that happens in space has to be a governmental mission. Not necessarily. So that's very exciting. That could be a huge game changer in some ways for astronomy, and it's coming from a very new and interesting source, as you say. So this is really exciting. Yes.
I want to go back to something you said a little earlier, and I'm a history buff. I still am. So you talked about all these bright objects like the comets and Hale-bops. You were editor when these bright comets came along, and then we saw the springing up of death mythology and suicide groups and real crazies because of Hale-Bopp. I remember specifically, but others too. How did you cover that? Did you try to teach that this was BS, or what did you do?
We really didn't cover it in the magazine in print so much because it was a quickly developing situation. We talked to lots and lots of people about it. Of course, there was no connection at all to the appearance of a comet. I mean, this is going back to what, people thought was happening, 3,000 years ago when a comet appeared in the sky. It was an omen of some, either good or evil. And most people, being human beings, they naturally thought it was evil. It's more fun that way, right? So, there's no connection whatsoever. There was no connection with toxic gases from Comet Halley in 1910 that people were worried about. The distance scale of the cosmos is really huge, even near us, in our solar system. So none of that stuff is an actual threat. And, the people who were amateur astronomers, quite honestly, thought the cult and, reacting to Hale-Bopp, it was just pure insanity, which it was, and unfortunately cost a number of people their lives for no apparent reason. But, we have a long, long way to go to get people to think rationally about these things, because a lot of people think about astronomy and space and what's going on out there just as they did 3,000 years ago. And that's a bit of a shame.
The other thing, and then I'll step aside again, is uh, extraterrestrial life, finding life in the universe. Um, what are your thoughts about that, having covered astronomy and being so involved in the universe and what's out there?
And forgive me, this is a little bit of an involved answer if I can, if we have the time.
Yeah, go
But
for it.
so my father was an organic chemist, and so this is close to home, some of this stuff. But we know through spectroscopy tells us that chemistry is uniform throughout the entire universe. Okay, the universe consists of maybe 400 billion stars in our Milky Way. The faintest stars, which are called M dwarfs, red dwarfs, are really faint over long distances. So we don't know exactly how many stars are in our galaxy. Something like that number. There are, we know, at least 100 billion galaxies in the universe. The visible universe, depending on dark energy, may not be the entire universe. So it's an enormous, incredibly large universe. We see that nearly all stars near us in the Milky Way galaxy have planetary systems. You would expect that. Again, not a surprise. We know the first samples of things that we've retrieved from comets or asteroids that we've studied have complex organic molecules in them. Again, not a surprise. So all these things suggest that life should be commonplace, spread abundantly throughout the universe. The whole heritage of human history of thinking, well, Earth is really special and unique, and it's the most important place there is in all of creation, is of course crazy. When the more you learn about astronomy and the universe. So we don't know. The only place we know of life in the cosmos thus far is right here. But the other thing that counters the discovery of that is that the universe, even really close to us, is huge on human scales. And I'll try to make this quick. But if we take the Earth-Sun distance, okay, that's one astronomical unit, as 1 centimeter, okay? We've traveled to the moon. We're traveling again now to the moon at an imperceptibly tiny fraction of that 1 centimeter that you couldn't even see on that scale. Okay. The edge of our solar system on that scale, Earth to the sun, that size, would be 10 football fields in one direction to the edge of to the Oort cloud, the edge of our solar system. The closest single star system, Alpha and Proxima Centauri, to us is 4 times more distant than that. So traveling around physically and having people land at Central Park and going to dinner at Tavern on the Green with them, with aliens, is exceptionally unlikely if you talk to real astrophysicists and talk about the energy that would be involved to move mass over large distances like that. But the existence of life, of advanced life, of civilizations throughout the universe, to think that we're somehow really unique and special, and well, this is the only place with life, or that there's not life all over our galaxy or the other galaxies, in my estimation, would be crazy and ignorant of chemistry, biology, and science.
If I ask you for the betting odds that a form of propulsion or transportation exist that would truly minimize these great distances and that we will discover it. Again, I don't know how old you are, but you're younger than me. So let's say your lifetime. What's the betting odds that? Would you give it 50-50 or less or more or what?
Well, you can't say never. You can't never say never. You
Right.
can't eliminate things as possibilities. But thus far, everything we know about physics and physical laws, which are laws in science are the highest you can get, include the relativity theory and gravitation and other things like that. There's no way that we can comprehend at this point to violate the laws of relativity. And that would move mass to a significant, even tiny fraction of the speed of light. We're seeing each other now. We're seeing photons from the sun bounce around the room here, coming through some windows. I have a light on here. We're doing a show. Those photons can move at 186,000 miles per second. Why? Because they're massless. Anything with mass, this is something that Einstein told us, with E equals mc squared, you can have my granddaughters who are 3 can eat a cracker and at their metabolism at that age, run around the house for half an hour and convert that matter into energy very efficiently. But you can't convert matter into energy and move at high velocities as far as Einsteinian relativity tells us, if you have any significant mass. Now, maybe there'll be things that we don't know. We are a long way from knowing everything about how the universe works. But all the evidence that we have thus far, at least, suggests that we won't have alien craft landing on Earth from star systems that are tens or dozens of light years away. It's just not energetically possible.
So give me your odds.
So the odds are very, very low. The odds of the existence of life, of significant advanced life, of civilizations, of lives that are where they're not, blowing each other up on the planet all the time, are unbelievably high throughout the whole universe. As Carl Sagan used to say, it may be kind of like there are 2 people on the planet here, and one of them is in Manhattan and the other one is in Australia, and they live their entire lives without running into each other. So the odds of having aliens showing up physically here, or us going to other star systems and just exploring and putting 300,000 roast beef dinners in the spacecraft, and landing there and discovering other life, are not good. However, the odds of discovering other life through SETI, the search of extraterrestrial intelligence. Jill Tarter is on our STARMUS board in Europe. She's the director of the SETI Institute. Seth Shostak, who's her right-hand guy at the SETI Institute, is a good friend. The odds of detecting a civilization through radio signals are vastly higher than ever encountering them physically. That could be done.
John Hunt, you've been waiting a long time for your question. Go for it.
And
Yeah, I
so-
want to get into that subject of dark energy, which is something I don't seem that people don't seem to present that way. The normal approach has been the so-called lambda CDM model, where you basically, well, from a mathematical point of view, it doesn't mess up Einstein's theory very much to put in a constant because the metric is a covariant derivative of 0. Okay, but I think that the better idea, if you go into this inflationary model of the universe, I don't know why we assume that this inflation field literally goes away completely. Why does it go down to some asymptotically low level and just slowly decline over the billions of years afterwards? And that, which within a reasonable period of time that we're looking at of a billion years or two, it looks constant. But in the longer term, like you're talking about, would probably just continue to go down. And I think that may be what's driving dark energy, as opposed to just a constant.
Well, and the answer is we don't know yet. And there are many, many cosmologists working on the dark energy problem now. The first group that solves it will undoubtedly get a Nobel Prize.
Yeah.
Nobody knows the answer to that. And so we don't in science assume that things could be completely different from what we already understand. We assume in science that what we understand is the basis of reality, and we modify what we know if we make absolute ironclad discoveries that further illuminate what the bedrock of science that we already believe we understand. That's how science progresses. Not to go on forever, forgive me, guys, but there was a book written about 30 years ago called Cosmic Discovery by Martin Harwood. He was a great astrophysicist at the Carnegie Institution. He estimated at that time, has changed a bit since then, but he thought we had discovered about 20% of the kinds of phenomena in the universe. There's a lot to learn yet. We don't want to get arrogant and think that we know everything, but we think that gravitation and relativity are scientific laws. And until they fail experiments that we've run now millions of times and they turn out the same way, that's a pretty good, that's the way science works. But we don't know everything. Absolutely.
Hey, Jay, you're next. You want to go?
Okay. Yeah. We had Bill Diamond here at the Cosmos Club about a few weeks ago or something like that, talking about SETI and other stuff. One of the questions that I have is for you is where are we? Are we closer to identifying all 7 terms in Drake equation, or are we now, closer to Fermi paradox? What is your opinion?
Well, we have a start, and we've only worked at the SETI Institute, and especially with the Allen Telescope Array in California. That's the fundamental instrumentation that's working out a SETI search now for about 30 years or so. So we're in the infant stages of this, and it's hard. I've talked to Seth and to Jill about this as well, and well, why don't, if there's a lot of life out there, it's a big universe and, electromagnetic radiation travels a long way. Why haven't we detected the civilizations yet, And the problem is that over long, long distances, first of all, you have to be pointing telescopes at exactly the right place at the right time. The other thing is that the signals lose energy over large distances, and that's the fundamental real challenge of SETI detections. Because if they didn't, then we'd see, quasars from the early universe would be even brighter than they are now. But so it's a really tricky needle in a haystack problem for the SETI searchers to try to detect a non-natural signal that is strong enough and that is exactly in the right spot in the sky at the right time. That hasn't been done yet. If it does happen, we'll know from Jill and Seth, but it's a very ambitious, very tricky problem. And it doesn't, again, looking at the numbers of star systems, conservatively, even 200 billion in our galaxy, 100 billion galaxies, the chemistry is the same everywhere. It would be a staggering thing if there weren't life spread all throughout the universe. But detecting it, again, is really, really hard because chiefly of the distances involved.
Yeah, of course, the Drake equation and Fermi paradox, at least the Drake equation confines itself to Milky Way, to our galaxy.
Yeah.
So does that make it any simpler, easier to, I
No.
mean, I'm asking a question about Drake's equation and Fermi paradox only as applied to Milky Way.
Yeah. And it would be the same, except for the distance from the Milky Way as in other galaxies. But the Drake equation, we don't know. We haven't solved it yet. We haven't found any civilizations. We don't know that it's accurate. Some astronomers who have found other complex planetary systems in recent years in stars mostly near us are increasing their estimates now of how many civilizations even they think exist just in the Milky Way because of the planetary systems now that seem to be abundant everywhere, which is, you would assume just from looking at the way stars and planets form.
Almost
but now
everywhere.
we have the evidence, and we're not even able to get down, for the most part, to detecting Earth-sized planets yet, because the technology is still evolving. Most of the planets we know about are gas giants and are rocky planets that are much larger than Earth. So we're in the early days of this understanding as well, of getting toward how accurate is the Drake equation. I knew Frank, I know Nadia, his daughter is still around.
Yeah.
It's a good estimation, but we don't know exactly how reliable it is yet because the technology hasn't quite caught up with it. I think in the next decade or two or three in our lifetime still, we'll be detecting Earth-sized planets around stars near us in the galaxy. We'll have a better idea how accurate the Drake equation is.
My question is, Gerard O'Neill talked about building these big, huge space stations and whole cities and so on. Now, being a lowly farmer, I'm basically talking about biospheres where I have my own farm.
Yeah.
And the thing is, when people move into space and start filling the Goldilocks zone, how will that change your publication?
Well, it'll make things much more interesting because, no one's really living in space, except briefly on the space station these days. But we don't have any sort of identifiable ecosystem in space at all. Despite the movies that I love to watch and enjoy, it's really hard to grow potatoes on Mars. No offense, Matt Damon. So eventually, again, all it takes is money. Those Gerard O'Neill illustrations, of the huge tubes, spherical tubes of societies and cities in space. All it takes is coin and we could get things like that started, and it's not easy because you don't have an infinite amount of breathable atmosphere and all that kind of stuff, so it's incredibly complex and unbelievably expensive. But technologically, you could be doing something like that and putting it into orbit or moving, again, 1 billion years, if we can manage not to destroy ourselves until the sun kills us on Earth, there's a long time to go in civilization here, so maybe in the future they will make colonies like that, put them into Earth orbit, move them over to Mars, who knows what. It's possible. All it takes is time, effort, and money. But there's nothing that's impossible about that and about some of the other early sci-fi stuff we love from those magazines long ago that you couldn't do if you put the resources into them.
Yeah. Well, how do you think it's going to affect your publication?
Yes, sorry about that. Yeah. Well, I don't think it's going to be happening next year. Again, the covers from sci-fi magazines from the 1930s of how we'll be driving aerial car helicopters, that hasn't really come to fruition yet. So I think it's going to be a long time to get that stuff really happening. But I think it would be a really interesting thing. Then you would have people living in space full time. You'd be able to observe, presumably, from those space stations, the universe in a much more effective way. We may have to, if Elon launches another 35,000 satellites. So it would really change the publication and the way people look at astronomy, I think. But I think we're a long way to get to something like that still at this point, I would venture to say.
Bill, did you have a question?
Yeah, I've got a couple of follow-ups that I wanted to do to things that have been discussed earlier.
Yeah.
First to jump back to Radio SETI for a second.
Yeah.
As our technology has evolved, we're doing less broadcasting and more narrowcasting using phased array antennas and lasers because it's efficient to broadcast. So doesn't that have an implication for Radio SETI?
It does, and it's an improvement, and it means that we don't have to joke so much about civilizations orbiting on planets orbiting stars near us, getting broadcasts of "I Love Lucy" and saying, "What the hell's going on with these people?" So it does. There are technological steps forward that's making SETI more efficient in terms of listening, but still, and Seth Shostak is a great guy. You could have on your program. You could get Jill as well if you want to, and they can articulate this much more detail than I can, of course. But it's a really staggering problem in terms of both distance and the coverage of the sky, to be able to have the good fortune to hear a signal that's close enough and that's directed and happening exactly at the time that you're listening. So a lot of people will say, well, we haven't heard a signal, so far, and they've run SETI for 35 years since Carl Sagan and friends got it going. Therefore, there's no life in the universe. That's not what it's all about at all. It's a really hard problem to make a detection like that, even with these more recent advances that you accurately describe.
Yeah, I mean, I guess I'm thinking when we first started thinking about Radio SETI, we were thinking that all these other civilizations were going to be doing what we're doing, which is spewing radio signals everywhere, right?
Yeah.
But are they really going to be doing that? I mean, aren't they going to be narrowcasting too, which dramatically decreases the probability of us hearing them?
They probably would be, but who knows? And I was brought up. I loved the original Star Trek as a child, watching the reruns. That I grew up, that stuff you couldn't get any better than that to get you going about science and the universe and everything. But I always like it that the aliens on Star Trek are bipedal, generally have two eyes, walk around, and somehow miraculously understand English. And in reality, if you look at if you talk to Dawkins and other people, the way life could evolve in so many ways, and cells reproduce and create organisms, there we could land on a planet, hypothetically, if we could somewhere, and see living creatures and not even recognize them as living beings. They could be so different than what we are, because of the evolution of life on Earth is one example. And there's so many variables, chemically and environmentally and otherwise, that life could be shockingly different in other places than what we're used to. So, you never know, but that's a great question.
Let me move us in a little bit different direction as we're approaching 90 minutes. So we have AI and we have robots, and many people, I heard it again this morning, believe that over time, these innovations are going to destroy us. They're going to take away our physical bodies by doing everything for us, lifting packages, self-driving cars, performing what we now do manually with our bodies that help keep us as somewhat fit human bodies. AI will be making our decisions, the critical thinking, the mental power will evolve into who knows what, and how we'll use our time, who knows what. Are you of the school that we maybe are at risk if we don't figure out a management way with AI and robotics and things that can replace a lot of what we do? Or do we let it happen and not worry about it? I'm curious as to your thoughts on all of this.
That's a really good and very timely question. And I tend to be a little bit skeptical of, magic happening and it eliminates the need for human beings and becomes a human-like entity that carries on and we're sort of out of business. We don't know, and it's very early days in the AI, revolution, if you will. It has already put a lot of people out of jobs. It will certainly do that. It'll certainly do a lot of mechanical things. Now, AI, however, I have to, and I know it's evolving very rapidly, and it gets better week by week by week. But remember, you go back a couple of years to ChatGPT, and there was a test page on the moon that concluded that it's rough conditions on the lunar surface, and there are only 23.6 million people who live on the moon. So that was an introduction to AI that we had at the magazine. So remember, AI is only as good as the information that is fed into it. Or that it can access. It's not magic. It's not an entity that exists in a superhuman way. It calculates and summarizes things very, very quickly, much more quickly than we could, from a huge body of information. But the information is created by people. So I don't see, I'm holding out, being a little bit of a skeptic, thinking that robots will not replace us all and that'll be the end of humanity in another 100 or 1,000 or 10,000 years. But they will change the economy and the way people act on Earth. They're already doing that. So I'm going to hold out on pushing them into a sci-fi movie where people no longer matter. I don't buy that yet.
And also, many people are really concerned about active SETI. So they go thumbs up on passive SETI. Active SETI is us broadcasting something and letting the whole world know that we are here and we taste really, really good. So what are your thoughts on active SETI?
We've already done that since the days of radio and TV, and I think if people see the episode of I Love Lucy, Carl used to talk about I Love Lucy being broadcast out there, and the pie episode, and he said, well, if people see that, no alien in their right mind would ever want to come to Earth. They'd avoid Earth at all costs, but so we don't know. But to actually try to contact or travel to, even more so, it's a really big place out there, even to get to the edge of our solar system. So I don't think actively broadcasting radiation of any type out there is going to bring in people who want to come in here and eat us, and we have to relive that great Twilight Zone episode, with the cookbook, which is fantastic. Because something that people who are really active amateur astronomers, even really into this stuff, really believe. I believe in empirical science to the end of the world. Don't really appreciate the distance scale of the universe. It's so big, on our scale, that you'd have to put most of a society's emphasis in traveling, toward a nearby star system, if it even is possible at all. So you'd have to have a damn good reason to want to go and visit someone, and I don't see anyone being that interested in human beings on Earth. No offense to any of us.
One thing about the intelligent life, and although, I mean, for instance, the dolphin may be a very sentient being and may have really great poetry and songs and so forth, and their
Yeah.
clicks. But
Yeah.
the point is, they can't really build anything technologically because they don't have the appendages of doing it.
Right.
So the kind of life that you might have showing up here might be look like human beings, but they would have to have certain features in order to have created the technologies to get us here.
Yeah.
That's one thing you'd have to look at. And they may
Yeah.
not be that different in general layout of having a couple of legs and a couple of arms and a couple of eyes and maybe three eyes. I don't know. You know what I'm saying? Eye in the back of the head, maybe. But you get what I'm saying. That
If you talk
they would have to have that general layout, I would think, maybe.
Well, you never know. And if you talk to Dawkins, I mean, evolution can go in a lot of different ways, and it happened to go the way it did here with us, but it could go in 50,000 other ways, developmentally. So that's the point he likes to make is that something, that you wouldn't be shaking hands with Klingons, put it that way. They would be at least somewhat different than human beings.
Well, the Star
Speaking of
Trek universe
fictional-
had too many advanced species that close together. I mean, even if you had the speeds that presumably these starships could go at with their warp drives, they still probably wouldn't be, like just a few stars over, right?
And it made for great shows. You could go back and refight the gunfight at the OK Corral and all kinds of great stuff.
Yeah, speaking of fictional aliens, Project Hail Mary takes this very issue on kind of interestingly.
Yeah. And the magazine folks promoted it a good bit. I saw it, was it last week? I think it was. I was a little disappointed because again, it didn't really, it assumed a lot of things that we know couldn't happen, which again, most all of my friends are big sci-fi readers, and I was always focused on the science because of what I had to do with the magazine, with pure science.
Yeah.
So, it was a good story. It was a great movie. It was great the way they filmed it. I thought the story was good, but a lot of moviegoers who see it are going to say that might actually happen. No, I'm afraid not,
No.
So anyway.
But the alien is an interesting life form.
Yeah. If you have
very, very different than a bipedal hominid.
If you have, and Star Trek had one of those dangerous rocks in the cave, that turned out to be a really good mom looking after her children.
Oh yeah, I remember that.
Kill Spock and Kirk and everything, but yeah, so that's that's at least there's a tip of the hat to plausibility there in some way.
Human expansion beyond Earth. So everyone here and a large part of our audience is a proponent of it, and also of tourism, of living in space settlement. It is costly. It is risky because we cherish human life. We don't dismiss it. And it's slow, sure. And because we're moving mass, it's really slow and needs a lot of energy to even get to the moon. Your thoughts on human expansion beyond Earth for whatever reason?
Well, it's certainly possible in the solar system. And, again, all it takes is time and money. So if you put enough, if everyone cooperated together and all the governments liked each other and we put a huge amount of resource into it, we could get a Martian mission going, and go there. Problem is, what's it going to do when you get there? Because unlike The Martian, a movie, by the way, great movie also, but, it's really, really cold on Mars, and when the sun is shining, it gets much warmer. But what are you going to do when it's minus 125 and you have all that you can do to eat you brought there, to try to build a space? It's a really difficult challenge to try to go there. And even as I mentioned before, the radiation exposure in space of going on a 3 or 4 month trip to Mars is really dangerous to living things. And last I checked, human beings are living things. Well, most of them, I won't get into politics, but so it's staggeringly ambitious and dangerous and risky. and would take an enormous amount of resource to say go to Mars and be there for a little while, let alone try to come back or build a base there. It could be done, but it's much, much more dangerous and difficult than it is shown in the popular media. But I hope we do it, and I hope we do it soon. I'd like to see it in my lifetime.
Do you think we have a place in expansion off Earth, whether it just be as far as Mars or maybe Europa can support life or something? I don't know. But do we have a place in doing that?
Do we have the right, say, to do it?
Well, I guess right could be included in, do we have a place? Is there room for us to do that? Is it something of value to society, to science, to humanity, life expectancy?
I think so. And again, if we don't, destroy ourselves in the meantime, or if an unknown asteroid or comet doesn't swoop in and as a civilization killer, we're going to be here for maybe as much as 1 billion years before this. The sun's a variable star, and so its energy, its bolometric output is increasing over time. In 1 billion years, it's going to be the end of the story of life on Earth, period. Long before, the evolution of the solar system later. But that aside, 1 billion years is a long time between friends, so I think going in that sense of exploration and discovery, there are resources, mineral resources, other kinds of resources on the moon, on Mars, and so on, that could be very valuable in the future. We're not going to have mineralogical resources to manufacture the stuff we'd like to have on Earth forever. So I think for a variety of reasons, it's really good. And I'm absolutely pro-human exploration as much as you can be. So I think we should do this kind of stuff. I hope we can allocate the money and resources to do it rather than, blowing each other up. It would be a lot more constructive rather than destructive. So I hope we do that. And I think that is in the future for us.
I wonder if someone listening or somebody has gone to the poly market to see what the odds are of human life continuing for 1 billion years or 1 million years.
It's only been a couple of million years back to our ancestors so far. We have a long way to go,
Yeah, but I'd love to see what the odds are on.
Right.
Does anyone have any additional questions or comments for our guests? Or David, do you have something that we've missed and we should bring up?
I want to make a comment.
Yeah.
I want to make a comment that one of the big problems with relativistic dynamics and all that is the term m equal to m0 divided by square root of 1 minus v square over c square. As velocity increases towards c, that term becomes so small, the square root term becomes so small that most of the energy goes into mass. And you cannot really increase the speed to whatever it is that you want, even to reach 0.5 times the speed of light is just almost impossible to do. Yeah. So I have, it's just not going to happen, unfortunately.
Yeah, but we can still have our sci-fi and enjoy that.
Yeah, you can still do that.
It would be a better world if people separated the real science from the science fiction and enjoyed our stories, but understood that there are limits. Now, if you overturn Einstein, I promise we'll do a cover story on any of you, whoever it is. Okay. But as far as we know, we're not going to be traveling at very high velocities. The whole black hole wormhole thing doesn't mean, I knew Stephen Hawking was on our board, Starmus board, dear departed now. Kip Thorne is a Starmus pal of ours. It doesn't matter if you try to travel through a wormhole. If the wormhole pulls you into a string of protons that's 10 kilometers long, where you come out in another part of the galaxy really doesn't matter, okay? So there are practical limitations to the theoretical or hypothetical possibilities too, to these stories, Yeah.
But they are definitely enjoyable, and that really does excite people. And, we talked about how people get excited, and certainly the late 60s Star Trek which ran for a few years, excited a lot of people.
Yeah.
So did Carl Sagan.
Yes.
At
Absolutely.
one
And
time.
I owe I wrote him when I started a little magazine as a teenager myself, and he encouraged me. In some way, I owe my career to Carl Sagan's encouragement of me. So he was a great, great guy. But we could travel to Europa, to Mars. We could,
That's right.
the solar system we have, those worlds,
Yeah,
that's all possible.
Yeah, let's cross that bridge first.
Yeah.
Have we missed anything with you? Do you have any thing you want to add or any closing comment or anything?
I don't think so. This has been a joy, and it's great to get to meet you guys and to know you. I think we covered so much stuff, and forgive me, some of these things you get talking on them, and there's a lot to say, so I rambled on a lot. Forgive me, but I think
Oh
we
no, it's
covered a lot
enjoyable, very enjoyable. Your this talk.
Well, thank you very much, and I think we covered all the major stuff I would have expected really nicely, and what a wonderful show you have here.
Final question, honest answer. Are you happy with the direction the Astronomy Magazine is going with the new editor and chief and staff?
Yeah, I think, it's a really challenging time for magazines. They've just announced this in the issue that just came out. So they're going to publish 2 less magazines per year, print magazines, and have 2 months that are just online. That's not going to make some people happy because the folks who subscribe to the print magazine want the print magazine,
Right.
So we'll see how that goes. But it's a good crew. I think they're doing really well. I hired these folks, so they better do a good job. I had been there for so long, and I've got other adventures I'm doing now, talking to you among them. So I'm really happy doing what I'm doing, and I think they're doing a good job.
What are you doing now? Where is your science and astronomy career taking you?
I'm doing more with the Starmus Festival. So Garrick Israelian, an astronomer in the Canary Islands, Brian May, who's an astronomer, he also plays guitar, a little bit of rock and roll. He's the guitarist of Queen. He and I and Garrick are working on the Starmus Festival, which is a European festival. We're going to have it again in the Canaries this fall. And then I'm also working with a New Mexico Observatory group and also writing for Astronomy and Sky and Telescope now too. So and a book project for the University of Arizona Press. So I'm managing to maybe be, as everyone I ever knew said, you're going to be busier after you retire. I may be the same way.
When your book is ready or you have another purpose in mind, let us know. We'd love to have you come back on the space show and talk with us.
Well, thank you so much. What a pleasure, David, it is to have visited with you. And thanks to all you guys. Great, great questions, and wonderful to meet you all.
Thank you very much, everybody.
Thank you.
Great weekend. Keep looking up while we still have a great sky to look up to. And again, no show on Easter. So if that's something you observe, happy Easter to you. And we are back with Bob Zubrin on Tuesday evening. And David, thank you again for being with us. Delightful is an understatement. It's been very informative and very enjoyable. And we appreciate your being here.
Thank you so much. It was great
Thank you.
fun. I'd love to come back sometime. Thank you.
Thank you. Bye-bye, everybody.
Bye-bye.
Bye.